Hi guys, my name's Ben Guilford. I'm the owner of the Vibrating company, and in this video we're going to take you through the basics of concreting. We're going to show you how to pour your concrete slab. Now that you've made your formwork, you've tied your reinforcing, we're going to take you through how to order and pour your concrete, and then some tips on how to finish it.
Reinforcing is in, it's all tied, it's sitting up on its plastic bar chairs, and the next step is ordering your concrete. Now, first thing to do is figure out the volume that's required. So get your surface area, multiply it by your thickness of 120 mil if that's what you've gone with. And then I usually add at least 10% to that to cover any wastage, any just maybe, I don't know, someone managed to tip a wheelbarrow over or something like that. You always allow some extra. What you're going to find is if you're ordering your concrete rather than mixing and pouring it yourself, there are minimum order quantities. In Australia, it's usually about 0.4 cubic meters, and that will be more than enough to pour this slab here. But figure out your area. It's a good bit of geometry for you, take you back to high school. And so figure out that volume from your area and order your concrete. Now, the concrete that you want to order, have a look in the written instructions that we've done for you. We actually specify all the different things that the concrete company is going to want to know. So they're going to want to know your volume, they're going to want to know the strength of the concrete, they're going to want to know the size of the stone in the concrete, they're also going to want to know the slump of the concrete. Now, the first few are pretty straightforward, so your volume is how much concrete you need. The strength of the concrete, we're recommending 40 MPa. 40 MPa is quite a strong mix. To put it in context, your standard driveway is usually done in 20 MPa. So MPa is megapascals. In the US, you'll be doing it in PSI, so we'll throw up the conversions for you. But for what we've got here, because it's a suspended slab, so it's hanging in midair, we want to go with something a bit stronger. And again, guys, because it's not very big, we can go with structural grade concrete and really not be throwing a whole lot of extra money at it. If you were pouring 100 square meters, you'd really want to sit down and say, all right, do we really need 40 MPa concrete? Can we get away with 32 or 25? But because we're doing something small, I say beef it up. So 40 MPa concrete. Size of the stone, usually 14 millimeter stone, is pretty standard. And then for the slump, we usually recommend 80 slump. So slump is basically a test of how stiff concrete is. And it's done with a cone test. I won't bore you with it. But basically, if it was 0 slump, it's rigid. It doesn't move. It doesn't even, it's just chunks of sort of unset concrete. At 200, it's soup. It's just basically liquid. So at 80, it's sort of a nice, it's a stiff mixture, but it flows really well. And once we get some vibration into it, you'll find it'll flow like water for you. But 80 slump is roughly what you're aiming for, okay? So we really recommend, if you can, getting your concrete made by a local mini mix or a concrete yard or batch plant, called different things in different places. Get your concrete made if you can. There's some places where it's just not practical and you do need to mix it yourself. There's some great guides out there on mixing your own concrete and sort of, I guess, recipes to use to get yourself a nice strong mix. Basically, if you can, we really recommend getting your concrete made by a local batch plant or mini mix yard, because they make incredible quality concrete. Whereas concrete that you're going to mix yourself, unless you're getting dry premix bags, it's very difficult to get the same sort of strength of concrete that you can get from one of those yards, because they're adding not just cement and sand and aggregate, but they're also adding in things like silica fume and fly ash and these other cementitious materials that add strength to the concrete that we just can't buy. One of the things I mentioned before was why is it that we do 120 mil thick concrete slab? Why not 60 mil? Why not 200 mil? And the answer is concrete cover. So our thickness is actually set by our cover to our reinforcing. So we want to allow, say, 40 or 50 mil underneath the reinforcing and 40 or 50 mil above the reinforcing. Okay, so here we've got our SL81 mesh. It's 8mm bar, and you'll notice in some sections it's 3 bars high. So you've got an 8, another 8, and then another 8 on top. It's 24 mil of steel. And so let's say we would have 40 mil cover. So we have 40 millimeters of concrete, then we have 24 millimeters of reinforcing, and another 40 millimeters of concrete above that. So 40 plus 24 plus 40 is 104. Now we're rounding up to 120 because that just allows for any inconsistencies in the steel. Make sure we're getting at least our 40 mil cover. Now some people would say, well, why don't we just go to 150 or 200? Go really thick. That'd be really strong? But it actually wouldn't be. Now, the reason for that is the self weight of the concrete. Let's exaggerate for a second. Let's say we make the slab like a foot thick, right? Really, really thick, 300 mil. The concrete, it has to hold up its own weight. So the thicker we make it, the more mass it has, and that puts a lot of stress into this reinforcing. So we're actually trying to go sort of to the minimum thickness. We don't want to go too thick because that just adds extra weight without adding any extra strength. Our concrete's ordered and is on the way. And so we want to make sure we're organized. We have everything ready for when the concrete gets here, because there's no more time after that. You usually get about half an hour with the truck when it gets there. That's usually free. After that, they start charging like wounded bulls. So make sure you're organized. All right, so have all your tools ready. So first thing, you need to have a shovel. So you need something for moving the concrete around. All right, shovel's really good for that. You will want to have a trowel, a float. Doesn't have to be this shape. But you need something for doing some work with it later on, for troweling the surface. You will need to have a concrete vibrator. Now, you can get away without the concrete vibrator if you vibrate the concrete yourself. If you jam, like the shovel into it and really sort of rattle the concrete around to get it to flow in around all the reinforcing and into all of these voids. Because when you see the concrete come, you're going to see it's not like a soup. It's really, really thick, and it needs vibration in order to move. So if you can, hire yourself a concrete vibrator. There's a few different models. You can get one with a sort of a motor that sits on the ground and it's got a long sort of snake thing that comes off it, or you can get the whippersnipper style one. Just get it and you just immerse it into concrete. You're going to vibrate an area, and then move to the next area, vibrate that, move to the next area, and vibrate that, and just dip it into the concrete gently and pull it out again gently, and just go in a bit of a grid, make sure that the entire slab gets vibrated. The other thing that you're going to need is a screed. So I've just got a bit of aluminium here. You could use a bit of wood. The whole thing is you just want something that's straight, it's flat. Because what we're going to do is we're going to put it across to the formwork on the other side. And then once the concrete is in, we're actually going to wiggle this back and forward and use it to flatten out this surface. And this is where these edges come into play. That's why it's so important to have these nice and straight, because your concrete is going to follow those. All right, now we're working into a corner, which is frankly a giant pain in the neck. If you're working on a simple rectangular stand, you can just go from the back to the front or vice versa. And you're going to basically push the concrete ahead. And you might need to add a little bit more if you've got a low spot. You can go back Start again. But you're going to want to have a screed, okay? That's what this is called. You can go and buy yourself a fancy concreting screed if you think you're going to use it again, or if you just love tools. But a nice straight bit of steel or timber is going to do the job as well. The last things you need, really very critical, you need some way of getting the concrete from the truck into your formwork. Now, if you're really fortunate, you'll be able to back the truck all the way up to your stand, and they'll just pump it straight out of the chute, straight into the formwork for you. We're not that lucky here, and that's usually not the case. Usually you'll be building your oven around the back of the house, and the access isn't that easy for a truck to get to. So there's a few ways of doing it. One way is, hey, just put it in a wheelbarrow. When you get there, you shovel it out of the wheelbarrow. That gets really old really fast. What I like to do is use a wheelbarrow and these cheap plastic tubs, these flexi tubs. Now, these are sold in lots and lots of hardware stores. They're only a few dollars. They're cheap things, but they're brilliant, because what you can do is put this in the wheelbarrow. This wheelbarrow has seen some stuff, I tell you. It's on its last legs. But the tub is what's actually holding the concrete. So I just put that under the chute. I tell the driver just to half fill it, because frankly I'm just not that strong to lift like 60 kilos of concrete at a time. So half fills the tub, wheel it over here, and then lift the tub out and put it in. In this case, I'm going to have to go stand at the back, but if I was near the front, if I could get all the way around, I could just lift it up and just dump it in and go and repeat. If you can get help, if you've got a friend, someone who can help you out with this step, it's a really good idea having two people. Having just one person doing it, you're under a bit of pressure because you've got the time factor of, you only got that half an hour with the truck. So have a think about whether or not you need some assistance. But that's your prep. Once you think your slab is full, so my formwork was basically full of concrete. He still had some concrete in the truck, and I got him to just give me another full tub and a little bit more, just in case. Because you can throw it away, but once that truck leaves, you're not getting any more concrete. The other thing that I would say is, a lot of these ovens are built in some gorgeous areas where, lovely al frescoes, maybe got some kitchen cabinetry and things like that. The vibrator will throw little spatters of concrete, and it can actually throw them like a reasonable distance. So cover things that you love, cover them with plastic or just some protective sheets or something, just to prevent any spatter from hitting them and sticking to them. At the end of the pour, the driver is going to want to wash out his truck. So either have a place in mind, maybe in your garden, you're happy for him to wash out a little bit of the wet concrete out of the chute, or you can provide him with another tub to wash out, because that chute that the concrete comes down is very dirty and they have to wash it before they get off site. Okay, so just keep that in mind. The driver is going to ask you, where can I wash out? So if you've already thought about that, it makes you look super smart and like you know what you're doing. Okay, so our concrete is on the way, but I thought while we're waiting, I might show you a couple of other things that you could think about doing if it suited you. So we've seen before people actually run power in near their oven. So you, for example, might want to have a light, that you can run off a power supply. And so you might want to cast in a conduit into your slab so that you can run cables through that. So if you're thinking about that, let's say, for example, you just wanted to do something really simple. You wanted to run a conduit through, just a hole through the slab. You could get a bit of plastic electrical conduit and attach that to your formwork in such a way that it doesn't move when you're concreting. All right, now that's something to think about, because there's a bunch of different ways you could do it. One way would be, say, to make a little piece of timber that fits into this and then screw into that from the underside of your formwork. Lots of different things that you could do, and you can take that idea further. You could say, well, I want to make quite a large void. Maybe you're planning on running some kind of something up through the slab, and you could put quite a large void in the slab. You need to cut your reinforcing to suit, making sure that you've got 40 mil of cover, but then you would simply attach some kind of block out to the formwork in such a way that it doesn't move while you're concreting. So that's things like conduit. You can run those through your slab. Just make sure they're not sitting against the bottom or against the surface of the concrete, because otherwise you're going to have a really weak point in your concrete. Okay, so if I was running, for example, a conduit through this slab, I would actually tie it to the reinforcing, which means it's not going to move around on me while I'm pouring. Something else that you could think about doing is installing some cast-in anchors. So you're building this incredibly strong concrete structure. Why not use it as something to build off, because it's so rigid. You can bolt steel onto it, you could bolt timber onto it. There's all kinds of different things that you could attach to it. Now, of course, you can do what we did with attaching the formwork. We drill a hole and you put in a concrete anchor. If you want to get really fancy, guys, there are what's called ferrules. Not feral, like a feral dog or feral cat, but ferrule. And this is a cast-in anchor. And so it's got a thread on the inside, and it's got sort of an expanded head. It's called an elephant foot. The idea is that this ends up inside the concrete and it grabs onto the concrete. So when you're trying to pull it out, you're actually engaging this big cone of concrete that it would have to dislodge in order to remove this. So these are incredibly strong. Now, to attach them, all you have to do is mark on your formwork where you want the ferrule to be, drill a hole through, put it on the inside, and then bolt it up from the other side. Okay, and then when you remove your formwork, you'll take this bolt out, you'll remove the formwork, and you'll see this little threaded ferrule there waiting for you to put a bolt into it. So, is it overkill? Yeah, it is. These are the kind of thing that you would use in bridge building. If you wanted to, say, put a handrail off the edge of a bridge, you'd cast in things like this. All right, so anyway, this is not the only video about concreting on YouTube. If you want to learn some more cool stuff, heaps of other videos out there. But this is just some little tips and tricks for getting the most out of this. In the form, we cleared our rails, so I'm going to show you guys how to go about screeding. Now, if I just try and drag this across the surface, I'm going to have a terrible time. This is not going to happen. Frankly, I'm just not strong enough. But it would also tear the wet concrete and sort of make a mess of it. So what we do is we actually work it backwards and forwards across the surface. Now, if you've got someone else with you and you can access the other side, you can have someone on that side and you saw it across the surface of the concrete. Another thing that can help is if you tilt the screed slightly up so that it's not trying to dig into the concrete, but rather it's sort of pushing over the top. Okay, now what you may find is, like I've done here, I've got too much concrete in this form. So when I'm screeding, I'm getting this build up here, which is presenting a lot of resistance. So what I'm going to do is get my shovel and I'm just going to take some of that out. Okay, now remember you can screed it several times, so you don't have to get it perfect on the first time. I can come back, start again. You can see here, I've actually got a little hole. So I can just get my trowel, just grab a little bit, and just pop that in there. Okay, so we've done our first screed. Now that's just to get the real bulk material off. Don't worry about, if it's not perfect or you've got a little hole or it doesn't, feel right. Concrete takes a bit of time to set. You've got probably, depending on your ambient temperatures, how hot it is outside, how windy it is, you might have a good 20 minutes, half an hour to do this. So don't panic. Take your time, get it right, and go over it a few times, screed it a few times. So I've done my first one, so now I'm going to go over it again, and that'll bring some of those fines up to the surface. So as I'm moving the screed back and forward, one of the things that's happening is it's actually pushing the stone down into the concrete, and the slurry is coming to the surface, which is what we want, because the slurry is what gives us that nice smooth finish. Okay, now this is just the first step. So once it's screeded, then, and we're pretty happy with how flat it is, we're going to leave it and we're going to let it start to set. And then I'm going to show you how to do steel troweling. So it is starting to look suspiciously like a slab. I've gone over using the sawing motion 3, maybe 4 times. On the first 2 passes, I had the screed just tilted back a little bit so that it wasn't grabbing, because it was trying to pull a lot of material across. Once I'd done the first 2 and I'd gotten the bulk of it off, I then just laid the screed flat and just worked it across. Now, for all the professional concreters out there, I apologize from the bottom of my heart, because I'm not a professional concreter, and maybe this is not what the apprentices are taught, and maybe this is not the classical way of doing it. But it does work, and it is a nice, simple way of doing it for someone who's never done concreting before. So concrete's nothing to be scared of. It is amazing material, as long as you know how it behaves. Now, so what I want to do is I want to go over it, and I'm going to tilt the screed back again, but instead of sawing, I'm just going to pass it over the surface, and it's just going to act like a big trowel and sort of float the surface. Hey, if you've got a big fancy float, go for it, like a big bull float. You could bull float this, but all I'm trying to do right now is get this surface roughly flat. Little dimples and things like that, don't worry. I'm not worried about those right now, because I'm going to come back and I'm going to trowel this surface, and I'm going to get those little dimples out later on. That's our slab in. Now, technically, we could leave it at this point. If you're going to tile over this surface later on, which the vast majority of people do, then we don't really need to do anything further from here. We can just let it set. Do need to keep an eye on it, and when it starts to turn, so once it's sort of taken its initial set, is the phrase. Once it's taken its initial set, we want to make sure it doesn't dry out too quickly. So once it has taken its initial set and you find it's firm to the touch, it's not wet and sloppy anymore, you can cover it with either a wet sheet, a wet hessian, or you could use a plastic sheet. The idea is to prevent the concrete from drying out too quickly. We want the concrete to cure, not to dry out. So again, if you haven't done much with concrete before, you may assume that you put water in concrete and it then dries out and sets. It actually doesn't happen that way. It's a chemical reaction with the water, and the water is consumed in that chemical reaction, which helps sort of create the chemical bonds in the concrete, which give it its strength. Now, if the concrete dries out rapidly, let's say, I don't know, it's a hot and windy day and you're outdoors, you may find you get what's called drying shrinkage cracking, or plastic shrinkage cracking. And that's effectively the concrete, instead of curing, it's drying. And so just like if you've ever seen the bottom of a dam, when it dries out, that clay cracks and shrinks, it's the same thing. We would get cracks through our slab, and we really want to avoid that. wherever we can. So to prevent it, we cover it with a wet sheet or wet hessian or with a sheet of plastic, and that's going to stop the water from escaping and effectively trap it in the concrete. Okay. Now if you use the wet sheet method or wet hessian, just lightly spray it with the hose every 12 hours or so. Just make sure you keep it wet. If it's really, really hot and really windy, you may have to keep the water up to it every hour or two. Obviously overnight shouldn't be an issue. But that's the idea. Now the reason we don't put it on until it's taken its initial set is because if we put it on now, well, the hessian is going to stick to the concrete, because this stuff, this is wet. It's really wet. Okay, and so we want to give it some time to start setting before we put our curing covers over it. All right, there. So what we're going to do is we're going to wait for it to take its initial set, and then I want to demonstrate a process called, not burnishing, but just doing a steel trowel finish. So it's allowing the concrete to set slightly, and then we go over it with a steel trowel, and that smoothens that surface. I can't do it now. If I try and do it now, it's too wet. I'm just going to make a mess. I have to wait until it starts to set. Our slab is still setting. We've got all our tools here and they're all covered in concrete and dirty. Clean up straight away, okay? So make sure you clean up your tools really thoroughly, because concrete sticks really well to metal. So I'm going to wash my screed, my shovel, my trowel, and the vibrator here, and get all of that nice and clean so that I can use it again in the case of the trowel, or I can put these away and use them for the next job. Been about an hour and a half, and our concrete has started to turn. It's started to set. You'll recall before it was really sloppy. Now it's sort of firm. Like I can push on that surface and it's resisting. I can still, make a bit of a mess, but I can't just plunge my finger all the way into it. Now we could wait a little bit longer, but I just want to demonstrate to you that it's not this really precise thing where you have to wait for the exact right moment before you start troweling the surface. You can get started when it's a little bit wetter, or you can wait a little longer and attack it when it's a bit firmer. The idea of what we're doing, you use a sort of large steel trowel around this size. You can get square ones, you can get all different shapes. I like this one. I like having this sort of boat shape at the end. I just find it gives me a little bit better control. And what we're trying to do is just smooth the surface, because we've got all these little dimples there, which are all the sort of the stones under the surface. And by working over the surface with the trowel, we're going to push the stones down a little bit and bring that slurry to the surface so we can get a really nice smooth finish. If you run your trowel over the surface pointing this way, you're going to dig in, right? If we go this way, and I'm exaggerating with these angles, if we hold the trowel this angle, it's going to glide over the surface. Now you don't want to be really aggressive, because you'll dig in with this bottom edge. So it's all about just very slight angles. So I'll put the trowel on the surface, and I'll just maybe, I've got this front up maybe about 5 mil or so, and I'll just glide across. I'm not putting a lot of pressure on. I'm just floating across that surface. You can see how I've got a low spot there, but if I keep going, I'm going to fill that in. So it's been another half an hour or so. I went and had a nice cup of tea, and it's starting to get a little bit firmer, so we can push on this surface now, and my finger's not really sinking in much at all. It's making a little impression, but not too much. And you may have noticed, the astute among you might have noticed that I didn't get to the back corner before, because frankly my arms, well, they're pretty long, they're not that long, and because I don't have a bull float, which is one of the long floats you see professional concreters using, I can't actually get to that. But what I can do is get a knee board. These can buy these at hardware stores. I actually just bought one because it makes kneeling down on the floor to work on things just a bit more comfortable for my old man knees. But you can actually put this on the surface and then kneel on that. That'll spread my weight out over a bigger area, and then I can get to that area at the back. Now, I certainly wouldn't be putting this on the concrete if it was still soft. I'd just go straight through it. But now that it has firmed up a bit, I can put this on here. It is going to make a little mark, but I'm going to then, once I've taken it off, I'll trowel the mark out. I'm going to be tiling over this surface later on. So technically, I don't really need to do too much troweling at all. But if you wanted to, you could keep troweling. So every 15 minutes, 20 minutes, you come back and you trowel again. And you'll find as the concrete gets harder, you press harder. And you'll end up burnishing the concrete. And there's whole, YouTube channels that are dedicated to that kind of concreting. And it's actually becoming very popular at the moment, as even in kitchens, people are actually doing concrete finishes as part of kitchen bench tops. And so you could do that kind of thing if you wanted to. What we're going to do is we're just going to do one more trowel over the surface, and then we're going to leave it because we're going to be tiling it later on. Before you put your sheet on, whether you're using a wet sheet or wet hessian or a plastic drop sheet or tarpaulin, just wait until the surface is hard enough that you're not going to leave a mark in it by putting that sheet on it. All right, so that can take some time. It really depends on where you are. If you're in a cold climate, you may have to wait longer. You will find that if you get your concrete mixed at a mini mix yard or a batch plant, they will put in admixtures. They'll put in special chemicals that will compensate for the varying climate that you're in. So if you're in a cold area, they can put in what's called a winter mix, which makes the concrete go off more quickly. And then if you're in a hot area, they'll put in a summer mix, which sort of retards the setting. And you're going to want to let that then set. We recommend for 7 days. Give it 7 days, and then the concrete develops a significant amount of its final strength over that first 7-day period. And after the 7-day period, you should be able to strip off the sides of your formwork without a problem and actually get started building on it. All right, now we don't recommend stripping off the underside of the formwork for at least 14 days so that you've really got plenty of strength in the concrete. Remember, this thing's going to be here for years and years and years, so it's not something that we recommend you rush. So having allowed your concrete slab to set for 7 days, we can take the plastic off and we can now take off the side forms. Behind me, there's water condensing on the surface of the plastic that's been trying to sort of evaporate out of the concrete. So by having that plastic there, we really minimize the amount of moisture that's escaping. I'm gonna leave the formwork underneath the slab on for the time being because there's no harm. We can take it off in another week or so. It doesn't slow us down at all, and it just means it's just got that little bit of additional support. Okay, so I want to talk to you a little bit about how we vibrated the concrete, because you can see here we have a little cavity. Now the reason we've got that there is we didn't vibrate this particular part of the concrete quite enough. Now it's not going to fall apart or anything like that. Don't worry, it's not an issue. We're going to fill this in later on. We'll just trowel some mortar into that, which will protect the steel behind it from any corrosion. But you can see this whole section, particularly just this bit here, there's quite a few of these little holes. They're called bug holes in construction. And you've got these little holes here, and that's just a good indication that we didn't really vibrate the concrete quite enough at this point. Whereas if you compare to the front face, we've got very few bug holes in that surface, which means we vibrated it really well. Another thing you can do, it is a little tricky sometimes to vibrate the concrete around the edges. You can actually just go around with a hammer or a mallet and just tap the formwork while the concrete's still wet. Just go around and tap the sides, and that helps. These are just little bubbles, and it helps those bubbles rise up to the surface and disperse. All right, so if you see something like this, don't panic. It's not going to be a problem for you. But this, imagine what would happen if we hadn't vibrated the concrete at all. We would have cavities everywhere, particularly underneath. We would have lots of holes and voids, and probably be able to actually see the reinforcing, which is a no-no. So make sure you vibrate your concrete well. Hey, you're building something that's going to last for a very long time, so it doesn't hurt to go out and hire one of those concrete vibrators. If you decide to do it the other way, where you're troweling the concrete and trying to vibrate it by hand, go for it. Just be very aggressive. Really make sure you really rod the concrete to try and get all the voids out of it. So we want to finish off this slab. There's a couple of things that we need to do. If you've used some silicone around the edges, you'll still have that silicone that'll tend to stick to the concrete much better than it sticks to your formwork. And so you need to go around and just chase that out with a screwdriver or a blade, just remove that. And then the other thing that you might want to do is just this top edge. You may want to file that down a little bit, just take the sharpness off it. For the sake of your shins, for one, when you're climbing up and down, but also it's a relatively weak edge when it's that sharp. So if we just file it down, just take a little bit off it, just makes it a bit stronger. You could use an ordinary metal file, or you could just use a fire brick. There's a couple of spares in your kit. So you can go over it with a brick. These bricks are incredibly tough. And I'm not taking off much at all, like a couple of millimeters, but just to take off that little lip that's on that edge. So that's basically the process of building this slab. We do have a couple more steps, but we're getting very close to the end. The final step for our suspended concrete slab is we're going to put in some crack control saw cuts. Now you'll see these every day. If you go anywhere that there's concrete, you're going to see lines in that concrete. You won't find huge unending expanses of concrete. They always have some very small cuts in them, usually at regular intervals, typically sort of a grid. And the idea there is those are crack control joints. The concrete wants to crack slightly. It needs some stress relieving cracks, particularly due to thermal expansion and contraction. So as concrete heats up, it wants to expand a little bit. As it cools down, it wants to contract a little bit. So it has to develop some very small cracks. Now, if we don't put any saw cuts in, the cracks will just go wherever they want, right? The idea of a crack control joint, which is what we're going to be making, is we're controlling where the cracks end up. The crack will be inside that joint, inside that cut that we're going to make, and we won't see it. Now, I will stress, you don't have to do this, okay? Most of the ovens that I built, I didn't bother putting crack control cuts in the slab. It's not critical, but I found that I would get a crack in that slab and it'd sort of go its own way. And it was a little annoying. I thought, what could I do better there? And I realized, well, if I put in those crack control joints, then I'm dictating where the cracks are going to end up, because the concrete is going to develop these tiny fractures along the line or the path of least resistance. Okay, so basically what we're going to do is we're going to cut in to a depth of about ½ an inch, or about 12 mil. We're just going to do a cut with a diamond blade on our angle grinder. So I'm going to mark out where I want my cuts to be, and then I'm just going to go and just cut to about 12 millimeters depth with my angle grinder. Okay, now if you want to know where to put, or where we recommend you put your crack control cuts, for your particular slab design, check out our website, because for each of our different stand designs, we also give you a sort of a crack control layout. Okay, so that's the principle behind what we're doing. I don't know if I've mentioned, but this slab is going to get at least a couple of hairline cracks in it, and that's completely normal. If you look up your local government specifications for concrete structures, which is, I tell you, it's a fascinating read, very exciting stuff, you'll find that they actually have a section that will be dedicated to concrete cracking. So that was actually a huge part of my previous job, was monitoring cracks in concrete, specifically in structural concrete, and making sure they didn't exceed certain values. When you get a crack in concrete, if it's reinforced properly, it's not a structural issue that the thing's going to fall apart, because the reinforcing is holding it all together. The issue is actually to do with water getting in and getting to your reinforcing and causing corrosion over decades. Okay, that's the way the government specifications will approach concrete cracking, not from the perspective so much of it's a structural problem where it's going to collapse and fall apart. It's more from a perspective of making sure that the crack isn't big enough to allow lots of oxygenated water to get in and attack the reinforcing. Okay, I know I'm going into a lot of detail on this. I'm probably bored half of you, but if you get the message that you don't really need to worry about small cracks in your concrete, then mission accomplished. That's what I'm trying to get across here. To make your saw cuts, you're just going to need yourself an angle grinder, corded, cordless, doesn't really matter, and a diamond blade. You can get them from pretty much any hardware store, and there are different blades for different materials, so make sure you get yourself a blade that's designed for cutting concrete. Alright, and one of the good things actually about this particular blade is that it has these little holes in it, which coincidentally are basically the depth that I'm trying to cut to. So when I'm cutting and the blade is spinning, I can actually use this line that I can see as the blade spinning as sort of a depth indicator, so that I don't go too shallow or too deep. It's not, doesn't have to be to the millimeter, but it's nice to know that you're cutting deep enough. Okay. Now in terms of safety, hey, make sure you wear all the right safety equipment. So you're going to be wanting to wear some hearing protection, obviously some eye protection. You might even, if you've got a face mask, go for it. If you want to wear one of those, some gloves, and probably one of the most important things, and sometimes gets overlooked, is a dust mask. Make sure you wear a good quality dust mask that's rated to, I think it's P2, which is a particle filter. When we're grinding concrete, we're releasing respirable silica. And respirable silica is a nasty, nasty thing, something we want to avoid. It's not asbestos, but it's not great. So make sure you wear a good quality mask and avoid breathing that dust in. Once you've done your saw cuts, you're going to want to clean those out really well. And then if you're outdoors, and so if the slab is going to be out in the rain, then we would recommend filling that crack with a flexible sealant. So a good quality exterior silicone will work really well, so that we haven't affected the cover to our reinforcing by putting that cut in the concrete. Okay, so that's basically the process of building your wood-fired oven stand. I haven't touched on a whole bunch of stuff. There's all kinds of things around concreting. It's a whole world. And there's lots of things that I haven't really covered. Things like, what if you wanted to do polished concrete? What if you wanted to put glow-in-the-dark pebbles into the mix and then do polished concrete? There's all kinds of weird and wonderful things that you can do with concrete. That is the process for building a stand for your wood-fired oven. And to be honest, and this is a feedback that we get from our customers all the time, if you can build the stand you can easily build one of our wood-fired oven kits. This is technically much harder than building one of our wood-fired oven kits. There's all kinds of, there's carpentry, there's working with concrete, there's all kinds of different processes in it, and it's very, very much a do-it-yourself thing where you've got to design your own stand and all of that. If you can do this, I'm very confident that you would have no problem building any of our wood-fired oven kits.